Record. Okay, now I'm starting. Hi, everyone. Again, to I would say not a new session, but a repeated session of the performance tips we had already. I don't remember, a year ago, roughly a year ago. You see my previous sessions, which will be covering almost the same topics today. I have a few updates, just a few changes, maybe a few different ideas in my head that changed over time. So I'm Robert, a support engineer at ZCOS, mainly supporting ZK. And today we talk about ZK performance, how to measure the performance, what we can, how we find out where the problem is. Ideally, we maybe get to the point where we can also what we can do about this if something is slow, and go through a few examples. As you can see, previously this session was quite long, so it took three sessions last time. We had to split it up into three because there were also some useful questions, which I'm happy to integrate. So I hope we get and make good progress today. And if something is boring, maybe it gets interesting if you ask them questions for the next session. Otherwise, we just go into the topic right away. So ZK performance. So of course, often, or not often, but in many cases, consideration that the application should be running fast, performant. Yeah, should feel snappy, should be reacting to user input, and also, of course, shouldn't waste resources on the server side. You can always throw more CPU power and more memory at something, but if you can reduce the footprint of memory and CPU, then you will get some, you will just avoid lots of problems right away. But before we can improve something, we always need to find out what's actually slow and where we can improve, or where's the most promising areas to improve. So that's why I always start with defining what is slow. Everyone has a different idea about what is slow. Someone says, I don't know, a slow CPU, it can be slow. A fast CPU can be slow, even though it's very fast. It depends on whether it's running or waiting. And there are different ways to detect what's actually going on. In many cases, it's just something waiting for some resources, waiting for network, waiting for CPU, waiting for memory to be available. And sometimes it's just really busy because some code is running really fast. And then it may be feeling slow, even though it's running at full speed and just never finish. So, and these things we can find down. So in order to figure out where the problem happens and what kind of problem this is, we created a flow chart that goes through these different, oh, that's the wrong browser. I just switch to my other browser. Give me the URL, copy. How to copy? I'll just copy this URL. By the way, I will always provide the source code and these links later as a download for those who are interested, and also the recording of the video. So you don't need to write this down right now. Otherwise, you can find in our developer reference, we have a step-by-step troubleshooting guide. And we always have this this breakdown chart. It looks very complicated, but I hope we designed it in a way so that we get to the problem very quickly. And I will show you the tools how to decide which branch to take. The ZK application is a web application, so we're always talking about. In most cases, we have some kind of server interaction, and we send a request to the server, we get a response, and something on the way is taking time. And the most, or in most cases, there's some kind of long-running request. If there's none, we will also find out. But if there's a long-running request, or if there's no long-running request, then of course it must be some kind of performance issue inside the browser. Then we look into the browser tools to figure out what's going on there. And if it's a long-running request, it could be a static resource, some kind of large file that's being downloaded or the server is waiting for. And then we can check the network and find out what it is. Maybe it's just really large. Maybe it's just downloading very slowly. Maybe it's waiting a long time to connect. Maybe it's failing to connect. So this is something we can also see in the developer tools of browsers. And if it's none of the above, then it's especially in the ZK application, one of these static page loading or dynamic page updating requests that go into your server logic, mostly your composers, your view models, to execute some logic and update the UI. And then there are, maybe I show this, and then there are 5 or 4 different things I always look out for. And that's also the first thing we can do. We just quickly show you inside the browser. Oh wait, this is the wrong, inside the browser. I need to start my server. I'll go into the project in a second. Just quickly go through the graph so we can see something. Come on, is it running? Okay, server is running. And whenever we click something in ZK, we get these kind of requests. And in order to open the developer tools in Chrome, it's here under tools, more tools, developer tools. Often it's the keyboard shortcut F12, so I always use F12. It's different on Mac, it's sometimes different on Linux, but I think in Firefox and in Chrome, it's either Control-Shift-I or F12. I think both work in both browsers. So if we click something, we always get some kind of nice breakdown in the network request about what is going on. Of course, you have to select, for example, everything. We just load the page again just to see what's happening. Yeah, we see there are some static resources. For example, this one is downloading. Here we can see that or this is what I mean in this chart. We have these sending, connecting, waiting, and receiving. So these kind of 4 stages of a request. We can see here, for example, there's a request to our page. And if we hover these items, we see the sending phase. How long does it take to start the request before it's executing? How long does it take to send? Here, 71 nanoseconds, so almost nothing. So that's really quick. Then how long does the server take to return the first byte? In this case, also very quick, 8 milliseconds. And because it's local host, so there's no delay, no latency. And then it took not even 1 millisecond to download the content. So we see already this is a very good request. And we can also see the download size is very small because the page is very small. This will be bigger for larger applications. Then ZK will, of course, download its resources, which are slightly bigger. Ideally, those are cached. In my test projects, I always disable the caches, but this is one thing you can always look out for. These kind of resources of ZK should be cached in a production environment, and they should not be downloaded every time you load a page. So if this doesn't work, either the caches are not enabled correctly, or there's a bug that we need to figure out, or some kind of other problems with the request headers or proxies or whatever can affect the caching capabilities of a request. So there are chances that this one is not working, and then but at least now it should be cacheable. So if you reload the page, these ones should be cached. Now you see they come from memory cache. There's one that can't be cached, the language, because it's session specific of a user, so it's different for every user, because this one contains locale specific JavaScript messages. And about the tablet DSP, need to figure out is a small file. Right now it's not our concern. And otherwise, everything is nicely cached here in this view. What did I say? Yeah, we have these kind of performance characteristics. So we have the send, we have the waiting time, we have the content download time, and these are reflected on our site. So if the sending takes really long, which is rare, it's either a very big request that's being sent, that's quite unusual, because very often you deal with user interactions, and users can't click a button a million times to produce a million click events that somehow queue up at client side. But if something goes wrong, there might be a weird loop that generates lots of events that fire at once to the server side. So it's rare. But if it is, it's either a big request that uploads very fast, or it's a small request that maybe just has some kind of low bandwidth or some other delays on the network. And very often, if it's a big request, it's a client-side issue. It shouldn't be big. There's not much except for big uploads. But then you already know you want to upload a huge file, so you will see, or you will know what you're doing. So you expect a big upload. Connection is something where we can rarely do something. It's about the network. Ask your network staff, ask your server provider why the connecting time takes a long time. There could be SSL connection, handshake. Lots of things can go wrong on the network level. I'm not an expert there, but it's visible in these charts here. Here we don't see a lot because I don't have SSL, I don't have proxies. More important for ZK application is the waiting time. When waiting time usually means the server is doing something or the server is waiting for something. That's something where we find out what is, so that's something we can profile where we can find out what is happening. So it's either, where do these lines go? So if the I can't follow the line. Sorry, I think waiting. I don't know if this is yes or no line. Something is missing there. Anyway, if it's waiting for a long time, it must be some kind of server-side issue. And then if we have a receiving issue, if the downloading time takes long, it's also, again, either a big response, could be a server issue if you don't expect a big response. It could be rendering 10 million rows instead of 10 if you only expect 10. So it could be some kind of server-side logic that goes wrong. And again, could be bandwidth. So we will focus today on what we see on the waiting side, what we see at the client side, or we focus on the client side issues and server side issues, how to find out what it is, and then potentially what to do about it. Okay, so that's this graph, there's the page, and there's lots of steps. I explain similarly what we can see here. There are a few more tools available that I'm explaining, and we will go through today. Okay, well, that's the performance graph. So we just look, we already looked into the browser and just do this for a real case. Now I've opened the basic problem scenarios where we can find out whether we are having a problem at client side, at server side, or somewhere in the middle, or maybe all of them, or maybe none of them. So for ZK, we often have XHR, which are these AJAX requests that update a page, and doc requests, which load pages. It could be something else, but in most cases, server-side logic is going through XHR. Sometimes if you have WebSockets, it's going through WebSockets. But whether or not you're using WebSockets or AJAX doesn't usually affect the server-side logic that's invoked. It will send the same requests just over a different channel. And for the XHR, for the AJAX requests, the tooling is slightly better because it's always a new request, so it's easier to see them in the list, because for WebSockets, it's just one request that has different messages in a different view, and it's not this nice. Okay, so what is the first button? Yeah, all these buttons do something slowly, but the question is how is it slow? Or where is the problem? Now, the first one we see, every user interaction that has a server-side event listener will send through our ZK AU. It's the asynchronous update servlet in ZK. And here we saw it took 3 seconds. That's already one thing. What we can check is the size is not big, so it's not unusually large. We can look a bit into the details, and we see it was our click event, and it was sent to this component with this ID. Has some data associated with it, which is irrelevant in this case, and it has a response that updates some UI. In our case, it just shows a notification with a text and some extra info about where to show it in the center and how long to stay and when to remove it. But why does it take 3 seconds? Yeah, So that we can see again in the breakdown, we have to hover this green thing, right? Reload the page. And then we click the button again, then it looks nicer in the waterfall view. Okay, so we see here we see waiting time. Yeah, if we remember from the graph, waiting time means server-side logic. So in this case, something at server-side was slow. That's what you will see if there's maybe a database request or a large operation to build some UI components. Takes a long time before the response is sent. And then the download again was quick, so no connection issue and not a huge response. And if you need more explanation, Google, Chrome are friendly to provide this. Similar tools exist in other browsers. I use Chrome because I'm most familiar with it. Of course, sometimes you have browser-specific performance issues, then you have to use the dedicated browser. Okay, the second one, yeah, it's slow in a different way. Also takes 3 seconds before it shows this message. Okay, but here we see in the request, wait, in the request we see, can we see this? Okay, it's too small, I can't hover. I need to make this larger, this area. Okay, maybe I can hover it now. Okay, it's just too far to the left. Need to reload again. Okay, there's my request. Because it's so quick, it's difficult to hover. But here we see everything was fast. It sent quickly. It didn't wait along at server side for logic, 14 milliseconds, and the response was instant. So it's not a server side issue, so it must be something at client side. How do we find out what to do at client? What happens at client side? Because we saw this, the message didn't appear early enough, so something must delay it. And for this, I would suggest to always use the performance tab. If we don't know what's happening at the client side, this will always give a nice overview about what's going on in a lot of detail. What I do is, here's the recording button, or here's the recording button. I just enable the recording, click the operation. That takes a long time. And when it's done, we stop it. Since this one is recording a lot of detail at client side, it often affects the client side performance and makes it a bit worse. But once we stop the recording, we can see this nice feature-rich graph. Now there's even more you can see here and more. So the detail is amazing. So they have done a great job doing these tools. What we see is, here's our network graph. So we see this is our quick request. It took 15 milliseconds. So that's not the problem. But what happened right after the request is some massive block of 5 seconds of JavaScript execution, which seemingly does nothing but to display this icon. So something went wrong. And if we look into this detail, we see, oh, the append child took a long time. Especially if you look at client side, I recommend enable the JavaScript debugging, so you will get meaningful function names at client side. Otherwise, this will be called maybe D or F or A, so it doesn't have, it only has a minified name, which is not really helpful when debugging these kind of problems. And here we see, well, something is just running a long time. What I usually like to show is that you click the append child method, and then you go into the breakdown further down at the bottom. And previously there was a, there's a link into a line of code where to go, but somehow the current version of Chrome has a bug, so you can't go to the line of code directly, which is slightly unfortunate. So we have to go there in the sources tab. I should have used the latest version because it's already fixed in Chrome. I posted a bug to the Chrome team, and they had it already fixed. They work faster than me, but they confirmed it, and I found the latest version has it. So on, I think in 1 or 2 versions, the fix will be available, and it will jump directly into line 191 if you click this one, and then you could see directly what is happening in 191. Here we would see DOM eval. So it's doing something at DOM level, appending some some children. Something takes a long time, so we don't really see what's going on here. Where is our code that is really happening? Performance, append child, and during append child, there's this anonymous function, anonymous. So we just see something is really, where's the script? Where's our script? Oh, it's executing some kind of script in the response. So if you have this kind of thing, you don't know what it means, send it to us and we will find it out for you. And also, if it happens after the response, often the response contains the clue about what's going on. So inside the network, in the response, we see that there is a script being executed. And the script will just count to 20 million and create new data objects. So it's, of course, a manufactured case. But the more complicated the JavaScript gets, the more easy it is to debug, because you see a more distinct performance graph and have more functions that are involved. But the key takeaway is you see this kind of block and you think, I'm not doing a lot. This one is doing a lot for a long time. I don't like it. Something is wrong. So I need to debug client side in the JavaScript, or call our support, me and my teammates. We will help you find out what's going on. Or maybe have a remote debugging session to test this directly in your environment if you can't share a reproducible code. So the next thing is there's another, or just go again. I'm more different. It's another client-side case where, wait, where's my network? Just clear it again. So I'm clicking this button. Nothing happens at all in the network for a while. And then suddenly there is one request. So this is just the opposite case. Some JavaScript before the request is keeping, is causing the waiting. So in the performance trace, it looks like, it just looks in the reverse way. Okay, so we just wait for it. We have this, come on, show me the picture. Yeah, we have this long block of JavaScript evaluation before our network request. So some kind of client-side listener. Here we see there is a do click fire X, so some kind of client-side click function is going on this page. Basic problem Zool, which means it's code inside our Zool file. If we check this in the sources, now we can go to our Zool file here. And here it already says 5 seconds are spent in this line. So these tools are really, really good. Now they'll show you exactly where the time is spent. So here you see, there's a loop. This loop takes 5 seconds. So, but just the jumping doesn't work right now. And the last one is just a combination of all the three. If you don't, very often you have a combination of multiple things. Yeah, there's a lot of things happening at server side, and the client side is also very busy. Then you need to figure out where's most of the time spent, where is it most beneficial to start optimizing or debugging. So we go again to the performance trace and we record the last button, or the second last button. It's even processing, and it's done. And here we see a more characteristic image of what's going on. Here we see some JavaScript here. We see a long request, 1 second, and we see some JavaScript after the request responded. So there is at least 3 areas that are worth investigating. But that's what these things look like. And in the last case, sometimes we get reports of bad performance when there is really no performance issue. That's the last one. For example, you have a network open. Now you check for this button. That's the wrong one. Stop. Clear. Reload. I want the last one. And it instantly responds and it shows processing forever. It doesn't stop. So we sometimes get this kind of error message that says, we have bad performance. It never finishes while it's completely idle. And then it's always worth looking into the errors. In this case, there's just a JavaScript error that happened that stopped everything from happening. And in this case, I made the error message even even very special that even the error handling doesn't work, because sometimes error handling fails for whatever reason, partially downloaded resources or whatever is broken in the response. So in this case, even the error function is missing, so you don't even see the error details on screen. So this can happen. I've seen this before, just to be aware. If you're looking in network, you can be caught up too much in the details and you miss to look at the console. So what I do is I often open the network tab, and then if you then hit escape, it also opens the console at the same time. Yeah, and then you can see both things happening at the same time. You clear this one, you clear the console, you refresh your screen, and then you click this button and you instantly see, there's just an error happening after the request. And what else can we see? You can always see who is initiating a request. If you don't know why a request is sent, you can go up the stack trace to see where the request is coming from. If there's a request that happens automatically without user interaction, causing problems, that's something you can look at. If these things, for example, work, they go to the place in the code. So this is about the Chrome developer tools. And now I also have a real life case. I don't know if there are any questions. I don't think right now. No. Okay. Is client config bad for usage in production? Yes. Don't do it. I mean, it's not bad, but it's not minifying the code. Right? It's the same JavaScript code. It should be the same. It could be different if you have some custom scripts that don't follow the naming convention, and it might pick up the wrong file, because you have to have, or you can have two files, the minified and the non-minified version. And if you have both files and they don't have the matching content, then the debug mode might behave differently than the real and the minified code. In ZK, this looks like this. We just check where we have this. For example, ZK XML, we have all our JavaScript in the package web. Yeah, I can show you what the WebSocket looks like. Give me a second. This is, I think here's Web.js, so I hope widget is good. So we just, what you see here is a window, a widget info.js and a source.js. So if you have custom components, these two files have to contain the same content, because this is the minified version for production, and this is the debug version containing all the commands and the non-minified code. So in production, I would only enable it on demand if really necessary. ZK should behave the same way, but as said, there's a chance that the files are out of sync if something went wrong. If the source file is missing, it doesn't matter. It will still only use the minified version. So you don't have to provide source files for everything. But if you do, they have to match. Otherwise, you get different behavior. For WebSockets, now we have to enable WebSockets first. I wonder if I have this prepared somewhere here. Not yet. Does someone know out of their head? No, I don't know. How to enable WebSockets? I always forget. Was a listener. I'll find it. Plus ZK WebSocket enable. I know there's a typo. Spring Boot integration. I think I have this here in the config. Why not? Somewhere, if I just search this one for WebSocket in this repository, there isn't many places, and it's this listener. And if we go back to our application and we just enable this here, just restart the server, we should have WebSockets enabled. Google Chrome here. And what we see then, because with WebSockets, since it's a persistent connections, you don't have a waiting time, you don't have the delay, you only have the timestamps when you receive and when you send data. But you don't see how long it takes to download something, but you see all the contents. So if I reload the page, I don't have WebSockets enabled for some reason. Always happens when I don't prepare something. Come on. This is failed logging. I don't have the logging enabled, so I don't see what's failing during startup. Let's see again. Is it using WebSockets? No, there should be a WebSocket channel. Okay, then I just go to ZK demo. ZK demo shouldn't be far. Oxycos demo. This one is using WebSockets definitely. And then we can quickly look about where to find the details. Somewhere is the WebSocket server push demo. And if we reload the browser, we should see our WebSocket request. It's just too squished. So here, the ZKWM is somehow ZK WebSocket messages. That's our endpoint. And here you see the messages being floating around. So if you click buttons, you see all the requests that go back and forth between ZK and client side. So easy to track. It's just more verbose and slightly less comfortable to look at. But you see the data size that's being sent around and the timestamps. So whenever you click something and you get a response, you will see the difference between the request and the response, and you can subtract yourself to figure out how long it took, what kind of latency you have from the server side. Hope that roughly explains the WebSockets. But if you're annoyed about this, you can always disable it and just test without WebSockets, because the performance characteristics at server side must be the same with or without WebSockets, except for the network latency. But it's the same request data that's sent to the server and the same response you get, independent of which channel you use. Yeah. So WebSocket, yeah, tools are there, just not as nice. I think it's newer or maybe more limited. And of course, it doesn't have the overhead of a real AJAX request, because it doesn't need all the handshaking time, it doesn't need request headers. So there's just pure data sending around and no other, or just less overhead. So it's usually more efficient, and the data is the same that's being sent around. So, and I think in Firefox you have a similar thing to look at WebSocket messages. Yeah, so where was I? Okay, we just disable this for now because it's not helpful for this session. Control Shift F9, Shift. Okay, so let's look at what time, half an hour. Okay, let's look at the special cases I created. I know the real life case. Yeah, this is also something. We had a bug recently about, or a bug request about combo boxes. Somehow combo boxes cause a problem whenever you click something. It's already fixed in the latest nightly version, but in 9.5.2 it's already there is this problem right now. So if you have lots of combo boxes, of course, who needs too many combo boxes? It happens. Sometimes you have many. There was this problem. That I'll just use the middle case. Now what I do here is I just quickly iterate over lists to generate lots of combo boxes. This will create 10 times 10 times 10, or 1,000 combo boxes. It's wrong. It's my reflex. So if we go back to this page, the real life combo box performance, we see the page is loading quite quickly. It's not beautiful. It's just many combo boxes. Each of them have their choices, so no surprise here. we can see the response is quite large. Maybe we didn't want so many combo boxes. So we have 10 kilobytes. If we enable the large rows, here's use large request rows, we can see the comparison between the compressed and the non-compressed response. So it was 10 kilobytes going over the network, and uncompressed, it's 200 kilobytes of info to generate components. So we see lots of combo boxes, combo items. So an easy way to debug if this is really the number of components you expect on your page. And then the performance issue was if you do anything else, yeah, I just click a button, yeah, it instantly replies, but suddenly the page is freezing, and freezing for a short time, about 3 seconds here in this case. And the more combo boxes you have, the freezing time scales quadratically. And this is a good case to check with the performance profiling tool. We just record, click any event. We just wait for this to, we can, for example, do a resize and wait for the browser to finish. Okay, it does this. And then we don't see the effect. Why? I think only the first time. Only the first time, after the first request. So we clear, we record again, we fire the event, we do something else. The browser is freezing, 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 updated. Okay. So we just see this unfortunate loop of madness here. So if you see something like this, it's most likely something gone really wrong, or you really want to do a lot of things. But in this case, we don't want to do a lot of things because you only clicked the button and none of the other components changed. It's just something that went wrong. It's a bug in ZK. It's something we already fixed. There's a workaround available. This is what it will look like. If we have a workaround available, we will make this available in the ticket. Wait, where is the link here? Just plus. Now, usually these things are contain something about performance, and we fix it in the latest version. This is our reproducing case, same as I do. Just provide some details about what are the characteristics. Scaling quadratically, it's always bad. And the workaround is, oh, here there's no workaround, it seems. Forgot, or maybe I forgot to add the workaround here. But there's, if you have blocking issues, to just get to us in support, and we try to provide workarounds or some kind of JavaScript patches based on what has been, how this has been fixed. Now, but here I provide the similar data. Yeah? You just see something is wrong. Check pop-up position. Yeah? It doesn't need to be checked when we click an unrelated button. Okay, so real life cases sometimes look like this, and then you often have really nice, like, teeth in this performance profile, and you see all the stack depth. The depth doesn't mean CPU usage, it just means how many methods are called in a nested way, in and out. And it's just too much happening here. Okay, this is the real life case. Just how to find some server-side issues. Now, the easiest case is to find some long, busy operation. If something is taking a long time at server side, if we see the request takes a long time to respond with the first byte, there must be something at server side. In this case here, I have my long, busy composer, and what it does is it's running in a loop, doing some not complicated, just doing some computation, and it's just waiting until some time has passed. So it's really a busy loop. It will use the CPU 100%. And for this, we need some kind of server-side debugging tool. The browser doesn't help us here. So what or one tool that's freely available is the JVisualVM. Or previously it was called JVisualVM. I think now it's called only VisualVM. And it was shipped with the JDK, I think until version 7. And since 8, it is maintained outside of JDK. So just open it, VisualVM. So from time to time, I check for updates. They're updating it regularly, not high frequently, but there's often an update. And then you see all your Java processes running, my IntelliJ, my environment, some Maven stuff, and my Jetty. Now you can double click it. It will give some details about the process. You can already see in the monitor whether how much memory is currently used, how much CPU is currently used. Right now it's idle. And then when we click this, when we click our button, when we click the long busy operation button, maybe the dev tools are a bit taking too much space. Long busy operation. We just click it, we see the CPU is going up. It's going up to 25% because I have 4 CPU cores. It's just looping in one thread in one core at 100%. And if we want to know what's going on here, the quickest way is always, it's tempting to use the profiler. The profiler is a bit tricky to set up, and it causes a lot of overhead in the JVM. So this is only for very tough cases when you need very exact timing and method count. But just to find out where to start, where to look into first is the CPU sampling is helpful. There's the CPU sampler, a memory sampler. Memory sampler is to count instances of objects, also really useful. And CPU sampling is to check which call stacks each Java thread is currently in. So if we enable the CPU sampling, I will start recording stuff. And if we then reload this page, which will initially just do this long busy operation, we will see something happening here, but not a lot. What we can do is we can enable the hotspots. And in the hotspots, we can see already which method is doing something very busily for 10 seconds. So this is the easiest case. If you have some busy loop at server side, something is just going crazy, you will find these in the hotspots very easily. Then you just check where is this coming from. It will show us, we first have to snapshot, and then we already know it was from the previous tab. We know it was long busy composer. So here we can also go to our hotspots. We see long busy composer, open the forward calls, and I think I just need more space. How can I make this bigger? Full screen. Okay, my screen sharing is slowing down. So here we see the call stack. It's starting at a Java thread. It's going through all the Jetty call stack. It's going through ZK. There's a DHTML layout servlet, which is responsible for rendering pages. This is configured in your web XML. And in the end, it reaches our long busy composer. And here it's just doing something for 10 seconds. Because it's self-time, it will be, because it's inside this, there's nothing below it. It's just something happening in this method. And we've seen this, there was this loop. So this is easy to find. It's more difficult to find waiting times because they don't create hotspots. Waiting times don't use CPU. So we have this next example. And also, this will be maybe much deeper in your application, but you can drill down which method call takes how much, and very easily with the sampling. And only if it's something really highly frequent or if you want to profile something very short and not like 10 seconds, it's better to use the profiler. And if you have problems with the profiler, ask me again. It's a bit too complicated to set up right now. I always get it wrong the first few times I try, so I don't do this live. And there are better profiling tools than this JVisual VM. So maybe it's then, maybe in your company you have a different tool for this. So what we can do is we try the slightly more difficult thing to debug is this long waiting operation. And if the server side is just idle for a long time, we don't see these hotspots. So how do we find what's going on there? So we just go here. Now you see in the log, it's something starts waiting, and in our long waiting composer, this is just representative for any database call that's waiting for a network response or file system writing, and when the CPU is not busy, when it's just waiting for the operating system IO things and finished waiting. So how do we trace this? We just stop the profile and start a new one, a sampler. So I start the sampling, and we already enabled the hotspots. And if we run this operation, I reload the page, and we don't see any hotspots. It's not doing anything here, because by default it doesn't show total time, it only shows self time. So when we go to total time, it shows us more details about other things that are going on. Still, it doesn't help us a lot, because everything is waiting in the system. Every thread that is currently idle is waiting, having no CPU time. So we need to filter a bit. Here we can filter, for example, for ZK servlets, or any kind of servlet, because we know it's a request going to the server. So any kind of servlet will receive a request. And here we see there is the layout servlet, our rendering servlet, which is good, and it takes 10 seconds. It doesn't have any CPU time, it's just taking 10 seconds. So again, take a snapshot, go to the hotspots, total time, search again, filtering for, we already know it's DHTML. Here we see 10 seconds. Just say, give me the calls outgoing from this, and then we can go in more into details and find out where the time is actually going. And it's going into our long waiting composer. And here we see, it's calling sleep. And very often this will be a network connect, network wait, network download, database query, something just waiting. Yes, the client performance on that's something where we go. For example, the scroll down is too bad, even when all data were loaded on client. Yes, if it's just too much, it's too much. There's not a lot I can do. If it's 10,000 times 20, it's 200,000 cells. And if these cells contain complicated things and complicated styles, the browser will just not be able to scroll efficiently if you render everything at once. So you need to do something, you need to do this kind of load on demand or render on demand strategy where the amount of data being rendered is less. Otherwise, it will just be busy rendering all the time. That's unfortunately the limits of what the browsers do. If there's something complicated to do, it will run at full speed. It's not slow, it's just really, really busy for a long time to update the styles, render all the pixels, and render all the fonts. That's why you need to avoid doing this. Use paging, use loading on demand to only load a small range of cells and rows, and not everything. That's what you can do. Yeah, you will see in the performance trace if you do the client-side profiling, you will see how the time is spent. And most likely, in this case, it could be CSS layouting, some kind of page reflows that take a long time because of complicated layout. Yeah, again, if performance is bad, you have to look into the trace to see what it is. And if we find something that is on our account, we can fix it. But if it's something that we can't fix, we can't help. So it's really a matter of figuring out what is causing the slowness. I've seen cases where it's just one CSS style that made everything slow. Sometimes we are lucky and it's something simple. Sometimes it's just too much for the browser. So it really depends on the actual scenario. So if this is bothering you, a really reported case, and we need something to look at to verify whether it's something we can change or we can't change. And sometimes it's possible, sometimes it's not. Sometimes it's a network that takes a long time to load more things. It really depends. So there's the render on demand is the thing to do. Just reduce the amount the browser has to render, and if this one doesn't help, somehow reduce the columns, reduce the complexity of the cells, render labels instead of complicated things inside cells. I think I have an example later about something, not later, maybe next session, not today. So we just go to the, what else did I have? Long async composer. I think I didn't use this anywhere. I wonder where I used this one. Maybe this was an example for some other case. What I also have is, now sometimes it's just memory. Now sometimes everything is slow because of high memory. And if you need a quick way to make a heap dump, yeah, we can load this page in the browser. And I also show you one specific case that is currently happening quite often, because browsers have changed something 2 years ago, and depending on which version you're on, this problem happens. So we use high memory. Yeah, in ZK, every browser tab has a corresponding and server-side object, which we call desktop impl objects. And if there's a lot of components or a lot of data stored in all your composers or components or in all the fields, this memory will be kept at server side, and each browser tab will be an instance of these. So this multiplies easily, and sometimes it fails to clean up these browser tabs when you close one of these browser tabs, or when you reload too often, and then you might have memory leaks. In order to find out what this is, or where the data is spent, you can easily take a heap dump here in this tool. You just go somewhere, take a heap dump. And right now, because I have one browser tab open, I would expect there to be one desktop object. This is always the first thing I look at in ZK. If I search for something, I just search for desktop. Yeah, and then you see desktop impl, there's one instance. Perfect, yeah, that's what we expect. And this one takes a while to compute, but this is very helpful to find out whether these desktops are large or not. So in my case, it will take quite short to compute because I don't have a large application, but in a big on a big server, this may take a long time. So it's best to test this somewhat in an isolated environment where not 10,000 users or 500 users are running at the same time. Now this is then easily too big, the heap dump. And here we see our desktop object is using 10 megabytes. And if this one wasn't cleaned up, we would have a memory leak of 10 megabytes, for example. And what we also see is in our summary, it already tells us there is a large object somewhere, a large byte array. So in this case, it's again simple. We just go there and just try to find where it's coming from. And here we see it's reference from our memory composer. This is really a trivial case. It's much more complicated, but in the heap dump you will see all the you will see everything that is related to where the memory is going. More interesting in this case is how the memory is behaving dynamically, and for this I really like this the memory sampling. Now, if we enable memory sampling, I'll just stop the CPU for a second, go to memory sampling, we see it's live counting objects. It's a really nice feature. And since we already know we are interested in desktops, we add a filter and say desktop impl. Here we see we have one live object of desktop impl. It's amazing. So if I'll just move this to the left and this to the right. Okay, if we just open the same tab again in another browser tab, yeah, live object increments to 2. That's what we expect. Perfect. Yeah. At any time you can take a heap dump if you want to see in more detail what this is, or if you reload a page. Now we can see that this number of object is sometimes going up, and then it's going down again. So let's see. Somehow the GC is happening too quickly now. I think they changed something in Java that my GC is running more quickly. Usually I would see this, see the number remaining. So I have to perform a GC manually in order to see how many objects are still in memory. So if I close a browser tab, Yeah, and I perform GC. I see the number goes down. So this means it can be cleaned up by the garbage collector. But sometimes it fails to clean up. If I just refresh very quickly, let's see if I can force this problem. And if I perform, because I still have one browser tab open, I perform GC, and now I have this memory leak that one desktop object remains in my memory. It doesn't get cleaned up anymore. So this is something that can happen in ZK. We are still working on a solution. We don't have a solution yet. For any kind of, well, for many different reasons, ZK can fail to send a specific request to the server to clean up. Just to make you aware of this request, what you need to watch out for is in the good case. In the good case, we have our network. We say preserve log because we reload the page. It would otherwise clear the logs. And we reload the page. We don't need the waterfall details. And we need the XHR and I think other. And here, if I reload the page, what we see is it's sending this request to the server before loading a new page. And this request is the one that's interesting. This is the remove desktop request. Unfortunately, Chrome, in this case, Chrome is worse. Chrome doesn't show a lot of details here. So we can only see the contents in Firefox here. I hope they improve this at some point. F12, and you open the same kind of network console, network, and I also have HTML, other XHR. Okay, reload the page and reload again. I need to where is the persist the log here? Does anyone see it? Persist logs. Okay, so I reload. And then I see this request here. And here we can see, hopefully, the request. Here we see this is the RM desktop, the remove desktop command, which will send the desktop ID to the server and to clean up. Yes, it's ZK version specific. I think I added the details. So this is the good case. Because it will try to send this request to the server when you close a page. Browsers try to prevent any unwanted interaction when you close a page, so you don't track you can't open pop-ups, you can't prevent the page from closing. So there's a lot of limitations of what you can do when a user is closing the browser tab. And that's why we had to change the implementation, because our previous implementation started failing. And this was done in ZK 8.62. Since then, we have the fix. Before this, we have a workaround with the watchdog, or when we need to patch the previous versions. The ticket about this is in my training notes. This one here. So this one is important. Otherwise, you will constantly have memory leaks if you don't get these remove desktop commands sent to the server. Yeah, it's this one. Future Chrome, since Chrome version 74, I think this one was failing and was fixed in 8.6.2, and this ticket already contains patches for these two other versions. So if there's a critical need, get to our support. And sometimes, of course, we recommend updating, but if it's actually impossible to update and the workaround with the watchdog doesn't help, then we can also patch. But here we have the Chrome issues. I wonder where the watchdog is. I think it's a related issue. Where are the links? Somehow I don't have the links here. Anyway, in case, if you can't deal with this problem, get to us and we can help. There's this. On the good side is whenever the session times out, the desktops are cleaned up again. So it's only a temporary memory leak. And also there won't be more desktops in your session than configured. You can configure the maximum of browser tabs a user can open. The default is 15, but you can set it down to 1 or 2 if you don't want more browser tabs to be open at one time. Yes, when the request response waiting time is too long, it's a server-side issue. That's what we saw in, just go quickly, just repeat. Yeah, it's always good to repeat something. So we have a long busy page. We say F12, go to the network, and we reload the page. Now here we see it's a request that, is it loading? Long busy. Here, so a page request could also be Ajax request. And when you see pending already, pending means either network or server side is taking a long time. And then we go into details, and here we see the waiting time. This means time to first byte. If the time to first byte takes a long time, it's in most cases it's server side logic, Java logic. In some cases, it's a proxy that is waiting for the response to finish and then sending the response at once. So it could be that the server is starting to send the response quickly, but somehow it's somehow queued or batched by a proxy server, a rare case. But normally you see a significant waiting time compared to the send and download time. Then you have, in most cases, this is when you start going into a server-side profiler, either in your developer tools. I think IntelliJ has a built-in profiler if you have the ultimate version, the pro version of this tool. But since I want to show something that everyone can use, I use the Visual VM, which was the standard tool in all JDKs, and is still available for free. Okay, let's see if I missed something. If some process is slow, which tool to use first, DevTools or Visual VM? First, DevTools. First, check the network. That's the first thing I look at, as shown in the performance, not in the graph, in the decision graph. And we always start from the top. Where was my, here, training notes? We just go there again. Always good to start or to reiterate, maybe just summarize what we talked today. So we've seen all this part, and the first thing is usually a long-running request. And a long-running request, identify the bottleneck. The first thing we do is, or I do, is I look into the network. Yeah, that's even before any decision. I just look into the network. That's the quickest thing. You see everything that's going on. Maybe there's many requests. Maybe there's one request. And if something is really slow at server side, it's usually one big request that takes a long time to respond. And then you see this based on this kind of time to first byte metric. Yeah, keep on trucking. There's no more time. We are running out of time today. Let's see if there's something I can say to wrap up. So yeah, what to do about it? Yeah, stay up to date. Make sure you don't have these issues, or get to us so we can assist. We have a performance tips page, which shows a few things, like we talked about render on demand. Then there are a few things in ZK, a few development methods that are sometimes more or less involved with CPU and memory. So if you really need the highest performance possible, use pure Java, because this is our richlet approach. Then there's no Zool parsing, there's no Zool parsing execution with reflection and whatever. So then you can skip all this templating execution. Otherwise, MVC, you still have direct access to the components, so you can also do parts in the style of a richlet. And MVVM is, of course, a fully controlled ZK data binding, where you try not to avoid the components. It's more convenient. It's a nicer separation of logic and the layout, but it has a cost. So if there's really an issue at server side, sometimes you find out that MVVM data bindings cause some memory allocation. And that's why if you use MVVM, or in general, if you use MVVM and the data bindings, try to get everything that is in an inner loop, in a cell somewhere very deeply nested. I use the static expressions over init bindings, which only execute once, and only the dynamic parts use load bindings or the bind annotation. But this is only relevant for MVVM users. So I think this would be something for the next next session. And then we can talk about how to avoid things and make a few more examples about what you can do. I think I will just provide these details anyway, and then we can go over this with examples in the next session. If you want to run the project, Maven Jetty run from command line. Quick hint: if you update Maven, and there was a security update in Maven just a few days ago, I think April 4th. It's Maven version 3.81. They're making it more strict to download resources only from HTTPS Maven repositories. And since we have an older version of Jasper reports, you need to configure the Jasper reports third-party repository directly, or exclude Jasper reports from your build. Otherwise, your Maven build will fail for ZK Max and ZKX dependencies. Just something happen out of the blue. It's good that they do it. It's just, don't be surprised. It's a good idea here, or a good way to tell everyone. If you update Maven, they also mentioned this on their website, that this is breaking change in Maven. And it's easy to work around, so that's why we don't have a high priority fix about it, but it will be fixed in the next version. Just be aware of it. Your application may suddenly just fail building if you upgrade Maven without any other changes. So it's just something I noticed when preparing this training just yesterday. And otherwise, if you run this from your IDE, you can run, you can pick the Maven profile. Here, the Maven profile Jetty runner, which will add something to the class path, and then you can run the main class Jetty runner. It's currently deprecated, but they promised me to keep it in Jetty for the future, so they they hopefully keep the Jetty runner, and just run source main web app to run the application directly from source. But this one I already covered, I think, last week or last session, when we talk about efficient development, how to run a ZK application from your IDE directly without installing it into a Tomcat. And if this was interesting, and if you think we should go over the extra examples we have here, we can go into binding cost, what I mentioned here, or other examples I have for part 3. There's a few more things you can do just to show a few patterns that save bandwidth in a follow-up session. All right. If there's more questions, now is a good time. Otherwise, I think I can stop the recording, and let us know if you need the. I think you already selected this in the invitation. If you need the recording and the source code. So I will say bye-bye for today. I will stay a bit in the chat in case there's something you want to tell in private you can't share. And yeah, thanks for joining today. See you next time. And bye-bye.